Hello, good afternoon. My name is Mustafa. I'm an application engineer at Intel. I'm based in Istanbul. I'm responsible for Internet of Things and artificial intelligence projects running throughout the region, and I have been delivering trainings and workshops. Today, I'm going to talk about one of the very most popular things, artificial intelligence, and how Intel is making it possible to bring artificial intelligence out of the data center and to the edge points to an industrial workspace. For Intel, artificial intelligence is one of the most important topics because we see it as one of the next waves. At first, we had the mainframe servers. After that, we had some standard servers. Later, we had some cloud servers. And right now, we are talking about artificial intelligence because the amount of data is increasing. We have some new algorithms, and we have the possibility to get the insight from the data. For Intel, artificial intelligence is very important because it's expected that all the loads on artificial intelligence will increase by 12 times from 1916 to 1920. Of course, it's a big money. Intel is interested in it. Artificial intelligence has been a study which has been talked about like since 1950s, but it is possible only today because today we have bigger amounts of data. We are collecting data from everywhere, from smartphones, from smart devices, from autonomous cars, from factories. And also today we have faster hardware. Intel is dedicated in creating hardware specifically for artificial intelligence. Also, we have been able to solve some theoretical problems, some problems about artificial intelligence. Artificial intelligence is transforming all industries, all verticals. For example, consumer, healthcare, finance. These are the verticals which are affected by artificial intelligence the quickest, and they are also able to adopt artificial intelligence the fastest. But also energy, transportation, and industry are also transformed by artificial intelligence. However, things are going slower in these fields. And of course, it's easy to understand why things are being adopted slowly in industry. We are talking about a flood of data. In 2020, here are some predictions by analysts from Cisco and Intel. An average person connected to internet will be creating like 1.5 gigabyte of data every day. And when you consider that there are billions of people on the earth, it makes a huge sum. A smart hospital will be making 3 terabytes, and a smart factory will be making 1 million gigabyte per day and every day. This is almost as the size of a medium-sized city. Of course, it's not possible to cope with this amount of data with all the traditional hardware and software. We need something specifically designed for artificial intelligence to handle these size of loads. Before going on, I should clarify something. Artificial intelligence is the study of making computer programs, making servers, making robots, which are able to solve some tasks like a human, and they show the cognitive abilities of humans. Machine learning is a very big field of artificial intelligence. Its aim is creating some models so that programmers will not need to consider about all the cases in advance. Instead, we create models from the data so that this model can extract the patterns inside the data, and when it faces any case, it will be able to decide, it will be able to predict. And deep learning is a smaller piece of artificial machine learning. It's some kind of machine learning, but it's mimicking human brain. We define some neural networks. Some neurons, they are designed in several layers, and they are able to capture different patterns inside the data. Deep learning has been a great breakthrough in artificial intelligence science because It has proven to be more efficient, more accurate than any ever classical machine learning algorithm. Deep learning can be used in pattern recognition, in computer vision, speech recognition or speech synthesis, or natural language processing. And also it has been used in industry and manufacturing. To give a few examples where deep learning is being used, for example, in healthcare, deep learning is employed in detecting tumors. And a deep learning model, the best deep learning model, can detect tumors better than an average doctor. Of course, it's not better than the best doctor ever, but it is performing better than an average doctor. Deep learning is being used in oil and gas exploration, and also in industry it's being used. For example, a use case is smart agricultural robotics. Here there's a smart vehicle used in agriculture. It has a lot of cameras in front of it. It is taking pictures in real time, and it's detecting if it's a good plant or not, if it's a corn stalk or not. If it's not, if it is bad for the field, it's removing them simply. And it's doing it in real time. In deep learning, actually in all machine learning models studies, there are two phases. Firstly, the training, and secondly, inferencing. In training, you get data, vast amount of data, and you generate a model from this data. After that, you test your data. You evaluate your data. If you are satisfied, you get your trained model, and you deploy it on your devices. It may be on a data center. It may be on an edge device, on a smart device, anywhere. And the second part is inferencing, or scoring, or testing, evaluating. This can be run on end devices. It can be running on a smart home appliance. It can be run in a factory. It can be running on an autonomous car, or it can be running on the data center as well. The first part is very computational, very heavy, and that part is for sure being done in data centers. The second part can be done both on data centers and also on the edge. And Intel has an end-to-end portfolio for artificial intelligence. Firstly, we have the Xeon 5 processors, CPUs, which are used in data centers. They are general purpose CPUs, and they are being used for training new models for deep learning and machine learning. We also have some FPGAs, which are used for inferencing in real time. They can be deployed at the edge points or at the data center both. And now we are working on a deep learning neural network processor, which is specifically designed for deep learning. Right now it's not on the market, it's only being tested by Facebook these days, but next year it will be in the market. And it's expected to increase the speed of deep learning training 100 times. And lastly, for inferencing at the edge, we have a new chip, a Movidius Vision Processing Unit. Today I will talk about the FPGAs and the Movidius chips. Intel has a very big portfolio for AI, targeting AI. At the bottom level, we have the devices, hardwares. We have CPUs ranging from Atoms to Xeons, Xeon 5s, and the new coming neural network processors. We are also designing new types of memories and storages and communication devices. On top of them, we are working on creating some libraries. We have our own Python distribution, which is optimized for Intel processors. We have some performance libraries. And on top of them, we are working for optimizing the frameworks. We are working with developers of TensorFlow, Caffe, Theano, with different teams, and we are optimizing all these frameworks, software frameworks, for Intel architecture. And on top of it, we have Computer Vision SDK, we have Nirvana Cloud, Nirvana Deep Learning Studio, which customers can create their own experiences. To bring artificial intelligence into edges, firstly, we have IoT gateways. We have a very wide range of IoT gateways. There are some very small IoT gateways which can be used at homes. There are some IoT gateways which are consuming very little power. But we also have some IoT gateways with Xeon processors. The processors, the CPUs that are used in the data centers. They can process very big amounts of data in real time. And these days we are talking about fog computing. After cloud computing, this is the new concept, fog computing. The computation is not only limited into the data center, but it's distributed. It will be everywhere. For accelerating your artificial intelligence workloads, you can use FPGAs. FPGAs are some little circuits, some chips, which you can download the electronical design on top of them. That's why they will be working the fastest, faster than any GPU or CPU. Today we have some FPGAs which can be plugged in the PCI slots. You can download your models, deep learning models on top of them, and you can make the inferencing in real life, in real time. Actually, these are the ones that are used for real-time computer vision tasks. And there are also some appliances with FPGAs which already have some kind of neural networks already installed on top of them, so that you will not need to design any software for it. You will not need to develop any software or design any electronics, but you can use what's already downloaded on them. And secondly, we have this Movidius vision processing unit. It's a new acquire of Intel 2 years ago. It's a small chip which is consuming very little power, only 1.2 watts. So that these chips are being used in smart drones, in smart bulbs, and also Google has just announced a few months ago Google Clips, a smart camera which is understanding what's happening around, and it's recording only when something interesting is happening, or when only it sees your face, your friends' faces. Today it's available as a chip. Yesterday it was announced, a few new devices were announced. It's possible to buy it in a small board as well. And it's also possible to buy it as a USB stick. You simply plug it on your device. It can be a laptop, it can be a Raspberry Pi, it can be any computer. And you do the hard computation work on top of it, and you get back the results. So Intel has a very wide range of portfolio for artificial intelligence, and today it's possible to make the artificial intelligence work also at the edge without sending all the data back and forth between the edge and the data center. Thank you very much for your attention. I will be around for your questions.